Building vocabulary. Match each term with its definition by writing the letter of the correct definition in the right column on the line beside the term in the left column. So, electric current is the continuous flow of electric charges through a material. Insulator is a material through which charge cannot easily flow. Resistance is the measure of how difficult it is for charges to flow through a material. Conductor, material through which a charge can easily flow. And electric circuit is a complete unbroken path through which electric charges can flow. Exercise 5. Enrich surge protectors. A surge protector is a device used to protect computers and other electronic equipment from surges in current or voltage. So from surges means either high or low, or fluctuations. An electric surge can be caused by a lightning strike on an electric line or when electronic devices that share a circuit are turned on or off. If you have computers in your classroom, they are probably plugged into a surge protector instead of directly into a wall outlet. One way to protect electronic devices from high voltage is to use a varistor. A varistor is another name for a variable resistor. You have learned that a resistor is something in a circuit that resists current. A variable resistor, however, is designed to provide very low resistance at high voltage and very high resistance at low voltage. Thus, when a surge of electric current travels from the wall outlet to a surge protector, the resistance of the varistor suddenly decreases and current passes through the surge protector instead of through the computer or other electronic device. Now at normal voltages, the resistance in the varistor remains high and the current passes into the electronic device. The graph below shows how the current passing through a typical varistor changes with increasing voltage. Briefly explaining the whole idea here, by using this diagram, suppose that this is the source of voltage and we have here the computer connected in one branch and the surge protector in the other branch. So what happens if this source provides high voltage or high current? In order to protect this computer, the surge protector, which includes a variable resistor, would decrease very much its resistance in order to allow the current pass through it instead of passing through the computer. Because now when the current reaches this point, it has two pathways. It checks out which one is easier for it to pass it through. So of course it would tend to pass it through a branch in which there is less resistance, which is the one including the surge protector. However, when the voltage is normal voltage and the current is normal and we want the computer actually to function, the surge protector increases its high resistance to prevent the current from passing through it and to force it to pass through the computer so that the computer functions normally. Now we can see that the current that passes through the surge protector as a function of voltage remains zero until the voltage is 330, then it increases rapidly. The current passing through the protector increases rapidly. So according to the graph, at about what voltage does the current exist in the varistor? At about 330 volts, it starts increasing above 0 milliamps. Why do you think the graph shows a large immediate increase in current after reaching a certain voltage rather than a small gradual current increase? This is because the varistor is designed to greatly decrease its resistance once a certain voltage has been reached. So directly it decreases its resistance. Okay, so there is a big difference in the resistance. Now that's why the current increases rapidly. We have also a big difference in the current, a big increase in the current. So once that voltage is detected, a large amount of current must be allowed to pass through the surge protector or the electronic device will be damaged. Now, suppose a surge protector had very low resistance at all voltages. What do you think would happen? If this is a true low resistance, then current will always tend to pass through the protector, whether it's high current or low current. It will always tend to pass through the protector with low resistance and not pass through the device, so the device won't function. So current would be diverted away from the electronic device at all voltages because there would be no current flowing into the device. It would not work. And suppose the surge protector now had a very high resistance at all voltages. So whether the voltage is normal, low, or high, this surge protector is always having a high resistance. Then the current would never pass through it and will always be passing through the electronic device. So in this case, if the voltage was high or the current was high, the electronic device may get burned, so the protector won't be able to protect it. So there would be current in the device at all voltages, and it would not be protected from the surges.